Okay. Are you ready? Can't wait. All right. This is still section 9.1 in our book. It's just kind of the second half of it. We're going to learn what a series is. A series is going to look similar to a sequence, but the word series means that you're going to be finding a sum. And it probably says this even though I'm writing it. You're going to be adding the terms of the sequence together. So we'll have a sequence. You put plus signs in between all of those terms. Your answer is the series. So as soon as we add in the plus signs, it becomes a series. There are finite series and infinite series. Notice my finite series would be 2 plus 4 plus 6 plus 8. I can find that answer. Here's an infinite series, 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus etc. I can also find that answer, kind of. Can you? You can't. Nick said he could. I was waiting for him to answer me, but he's on his calculator doing something else. Did you say you could find the answer? Oh, you couldn't find the answer? Oh, I'm sorry. I thought you nodded. Did you nod? Can anybody find the answer for this one? Sorry. This one. What's 2 plus 4 plus 6 plus 8 plus 10 plus 12? It's infinity. Exactly. We can find an answer. Oh, you're back. I did not know.
I'm back.
Hey, guess what? Well, no, I do. I'm borrowing one. But I got to turn this back in. So thank you. I lost my stylus. I don't know where it went. Okay, so yeah, that one would be just infinity because you're just going to keep adding on bigger and bigger and bigger numbers. So it's going to eventually hit infinity. Oh no. As soon as he comes in, this doesn't work. Okay, we're going to use what's called summation notation to write a series. So we're going to take those finite series and the infinite series, and the notes have rewritten them in summation notation. So I'm going to zoom in here. This is summation notation. It has a sigma. That's a Greek letter, a sigma. At the very bottom, it has a variable. I don't like how they use I. I almost never use I. We can use other variables, but they use I as a variable, not as an imaginary number, okay? And they're saying at the bottom, I equals 1. At the top, they're saying 4. That means we're going to plug in 1, 2, 3, and 4. And we're going to find those answers. So if I plug in 1 into this equation right here, I will have 2 times 1. Plus, I'm going to plug in 2. 2 times 2. Plus, I plug in 3. 2 times 3. Plus, and then 2 times 4. That's what sigma notation says to do. It says add plugging in 1 through plugging in 4 into this A sub n or I sub n formula. And then that answer will be the series. And this one here says the exact same thing, except for we're plugging in 1, and then we're plugging in 2, and then we're plugging in 3, and we keep plugging in numbers all the way to infinity. And eventually that's going to equal infinity because it's just going to be adding bigger and bigger and bigger numbers. A couple of vocabulary words. The index of summation is I. That's its index. The lower limit of summation is 1. And the upper limit of summation is 4. So the lower limit is that first number you're plugging in, and the upper limit would be the last number you're plugging in. The variable we're plugging it into is the index. So we are going to write some series using summation notation. So the first thing I want you to do, and I'm not going to say anything for a moment, is question A and question B. I want you to do what you're supposed to do from last class. Just figure out that A sub n formula. Figure out how we get anything in that sequence. And if you already have that one, do the second one because we got to do both. So I have people already writing it with the sigma notation and everything. That's even doing more than I actually asked you to do. I just want you to find the pattern, the formula for the equation, or like the equation. If you know how to write it in the sigma notation, that's fine too. I'm just going to go over that once we have it written. Hopefully you noticed that from 25 to 50, we're adding 25, and then we're adding 25 again, and we keep adding 25 until we get to 250. So this is linear. And when it's linear and that number I'm adding is going to be the number that's with the variable. And I just have to make sure that's it. There isn't any like +2, -4, anything else to that pattern. And there isn't. So we will get, this is what you were doing last class. We would get 25n. Now we are doing summation notation. So I'm going to think about it the exact same way, only I'm going to have this sigma, and I'm going to pick a variable. The book was using I. They are going to change it up, so I'm going to change it up right now. K. Why not? The first number that I plug in to get 25 would be 1. So I'm going to start with a 1 down here. And then the last number that I plug in that gives me 250 is going to be what number? 10. That's the last number that I plug in. So the number on top will be 10. So the first number I plug in is 1. The last number I plug in, I figured out using my formula, is 10. And then the formula, instead of putting an n in it, I have to use the variable that I chose at the bottom, is going to be 25k. So that's how you write it in sigma notation. If you wrote 25i because you chose I, that's fine. If you chose n and you wrote 25n, that's great. I don't care which letter you use. If it's a Canvas form and I need you to use all the same letters so it'll grade it for us, I will tell you to use which letters, okay? All right, question B. I saw a lot of people come up with this really quickly, which is awesome because this one's a fraction one. But we noticed 1, 2, 3, 4. Oh, that's the n. Right on top, that's just n. On the bottom, it's 1 plus 1, it's 2 plus 1, it's 3 plus 1, it's 4 plus 1. So that is also an n, but plus 1. So we're going to write that in sigma notation. We'll have that sigma E. And my formula is going to be, I'll use n this time, n over n plus 1. That means at the bottom I have n equals, I'm plugging in 1 first. And then what's the last thing I'm going to plug in to this series? Huh? infinity. Because you see it has a dot, dot, dot? That means it goes on forever. So on top, infinity. So that's my formula for that one. Okay, I'm going to pause the video for a moment. You guys, there's 4 for you to try. Let's see how quickly we can get through them. Okay, so this one we've got sigma. I'll use K equals 1, 2, and then what's the top number? 20, thank you. And then we've got 5K. Number 10, sigma. I'll use I this time. We're going to start at 1. We're going to end at infinity because of the dot, dot, dot. The formula on top is I. And on the bottom, oh, just kidding, it's I squared. And then on the bottom, it's I squared plus 1. So the bottom was just square it and then add 1. For number 11, sigma. X equals 1 to infinity. And what formula, Sarah Nold, what formula did you have? So I'm going to put 6 to the x because I used x, but yeah, you got it. All right, and then 12, we've got sigma, and I don't even know what other letters they normally use. K, I, K, K, I, okay, whatever. I'm going to use a J. J equals 1. And if we start at 1, let me figure that formula out first. If the first number I'm plugging in is 1, how can I get a 5 from that? Chris, do you have it?
I just put plus 5 plus 5.
So 5 plus 1 would be 6. Can you tweak your formula a little bit so it equals 5? You told me this. You said I, but
Yeah, I know that I did wrong.
yeah. So can we tweak this formula so that if I do plus 1, it equals 5? And then for the second one, plus 2 equals 6. And this number has to be the same every time.
So it would be 4 plus 2.
Yes, it'd be 4 plus or j plus 4 or 4 plus j, either way. And then if I'm doing plus 4, what is the last number I plug in to equal 12? 8. That would be the last number. So I'd have 4 plus 8 to equal 12. So 8 would be my top number. Now, I was helping somebody else, and they had something different on their paper. So I wanted to show you what they had, and maybe you had something different too. Can't imagine every single person did it the exact same way, but maybe. I don't know what letter they used, but I'm going to use I. They had I equals, what was your bottom number? 4. And then her formula was I plus 1. Whatever. I couldn't remember what letter you had. So she said, let's plug in 4 first. So if she's just adding 1 each time, then she put 11 at the top. So we're going to plug in 4, 5, 6, 7, 8, 9, 10, 11. These are both fine. Both of those work. You don't have to plug in 1 every single time.
So would you still accept if they did like j equals 5 at the bottom and just had to decide j?
If you did j equals 5, hold on a second, separate color. If you did j equals 5, let me do a different letter, x equals 5. Then what would be your formula?
X.
So that means, yeah, so that, yeah, You could do it that way. So that means then you would plug in 12 left. Yes, totally. Those all work.
Okay, I was just wondering if we had to like have something. Oh, never mind.
You mean if there had to be like adding something or
Yeah.
not necessarily if it's the input and the output are exactly the same. All right, finding the sum of a series. So we're going to find the sum of this one. And then this says over here, notice that, or maybe it doesn't say that. Yeah, it does. It's just talking about make sure that we're using the correct lower and upper summations, limits for the summations. Notice that it starts with a 4 and ends with an 8. So that means the first thing that I'm plugging in is 4. So my first term, my a sub 1, is actually plugging in 4. So I would have 3 plus 4 squared, which is 19. So if I were writing, you know, if I wanted to know the first term, you guys would tell me 19. Even though we plugged in 4, that's our first term. So then I do a sub 2, and I'm going to plug in 5. I have my a sub 3. I'm going to plug in 6. You guys can plug those in while I'm just talking. A sub 4, I'm plugging in 7. And a sub 5, I'm plugging in 8. So once I find my a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, I need to add those together. There will be parts of quizzes and tests that are non-calculator. Where do you think this might be on a quiz or a test? Non-calculator or calculator? Probably non-calculator. Can you add 2-digit numbers without a calculator? Yes. Do you prefer to? Probably not, but you can. Okay, and one of the reasons why this would be a non-calculator question is because you can actually type that entire thing into your calculator, which I'll show you later in class. So if I need to know, you know what this means and can do it by hand, I'll not make the numbers horrible, but this would be a non-calculator question. Did anybody do it using their calculator? Anybody add these for me yet? Yeah, what'd you get?
205.
Anybody want to confirm it is 205? That's what you got also? Okay. I'm gonna believe you. I don't want to like take the time to do it right now. So that's the sum of the series. We have some formulas for special series. If you see sum of n terms of 1, okay, if you have sum of n terms of 1, for example, if you have something like I equals 1 to, give me an n, any number, 100, okay, 100. And then there is a 1 sitting here. That is telling me my first term, when I plug in 1 into the variable that's not there, that's telling me I will have 1 plus. Now I'm going to plug in 2, but there's no variable to plug it in. So what's my answer for just the second term? 1. And then when I plug in 3, there's nothing to plug it into, so I'm getting 1, ... So this answer is just whatever n was, 100. So that's what it's saying. The sum of the first positive integers. The sum of the first positive integers. This would be a question where I say, and I'm just going to go say it right over here, add the first 100 numbers, like integers, starting at 1. I didn't write all the words in there. Starting at 1, I want you to add together the first 100 integers. One plus 2 is 3, plus 3 is 6, plus 6 is 4, plus, no, 10. What? I already got confused. Do you think there's an easier way? Yes, we're not going to sit here forever waiting for you to add up a bunch of numbers. And oh my gosh, I'm going to tell you right now, because it happens every single year. If you don't know how to do this, and I see a list of a bunch of numbers just being added up because you didn't learn the pre-calculus, you're not going to get credit even if you add the first 100 numbers correct. You understand? The pre-calculus is, do you know the formula? Do you know how to use the formula? Okay? It's not, can you add the first 100 numbers? That's not the question. So the first 100 numbers, or any amount, we have this formula right here that says take n, which is the 100 that I'm talking about, and multiply that by n plus 1, and then divide by 2, and that'll be the answer every single time. So putting this into a sigma notation, I would have I equals 1 to 100, and then I would have I right here. But we have to add them all up. So to shorten that, n would be 100. You're going to multiply that by 101, and then we're going to divide by 2. This is a non-calculator question. 10100 divided by 2. 550. Now, I just want to remind you that n is the number of numbers we're adding up. It's the number of numbers we're adding up. That makes sense. So I could change this question and no, I'm not going to change it yet. Not quite yet. I'm going to come back to this later. Okay. And then the sum of the first n, the sum of the squares of the first n positive integers, you will take how many integers? You'll multiply that by the number of integers plus 1, and then you'll multiply that by 2 times the number of integers plus 1. We have a formula sitting here divided by 6. We are going to start accumulating a bunch of formulas, so I will let you know you will get formulas for assessments. Once we start having a ton of formulas, you're just going to need to know how to use them. Like, I'll give you a formula, but I'm not going to say n is this number, and s stands for this, and r stands for this. You just have to know what they stand for, but that way you don't have to like memorize the formulas. Okay, here we have solving a real life problem. You work in a grocery store, and you are stacking apples in the shape of a square pyramid with 7 layers. We're going to write a rule for the number of apples in each layer. We're not going to graph it. It says then graph it. We're not going to graph it. Okay. So in the first layer, how many apples? A sub 1. Top layer. 1. A sub 2 would be the second layer. It's kind of hard to see. But if we've got 1 apple on top, we're going to have like 4 apples underneath it. So it sits right in the center of those 4 apples. Maybe I should draw it looking down on it. So we've got our 1 on top. The second layer would be dot, 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 so that my top layer would fit right in there. Okay. My third layer. I need 4 holes for the second layer apples to sit. I need 4 holes. So I need a hole. Oops, I'm making my holes in blue. I need a hole, I need a hole, I need a hole, and I need a hole. And then I need the apples to support those. So I need an apple here, I need an apple, I need an apple here, I need one here, I need one here, I need one here, 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 and here. So my third layer, how many apples do I have? I have 9. Do we sense a pattern? A sub 4 would be how many apples? 16 is correct. So we're finding all of these. I feel like I know the pattern now. I'm not going to waste my time counting apples. So A sub n, what would be the rule for any number, any layer? Like if I want to know how many would be in the 100th layer. That's a really big, tall apple stack. Wow. It would be n squared. Exactly. So now we're going to apply that to example 6. How many apples are in this stack total? How many apples are in the stack total? Let's use summation. And I'll use I. I is going to start at first layer, so 1. And then we are plugging in till we plug in, what's the last number I'm going to plug in? 7. And my formula is going to be I squared. So we can add all 7 of those up by hand, or there might be a formula that makes that go a little bit shorter. Is there a formula that makes that a little bit shorter? Is there a formula, Caleb? Do you see a formula that makes this shorter? Or should I just add it up all by hand? I don't want to add them up.
The sum of the squares.
Right, we're doing the sum of the first n positive squares. So we're going to use n times n plus 1 times 2n plus 1 divided by 6. So we're going to have 7 multiplied by 8 multiplied by 15 divided by 6. That might not even seem that much better than adding them all up. But first of all, that's the pre-calculus. Second of all, I can cancel some stuff and make it a little bit quicker for multiplying. So how about I do 7 times 20 instead? So I got 140 apples. So now you can work in the produce section. See? Education pays. No, you guys don't think I'm funny at all. Okay, cool. Okay, so we've got a few examples. I want you guys to find the sum. We are not doing these with a calculator. We are doing these with either the formula or you're adding them up yourself. Okay? Okay, so my work is up. Number 13 is kind of like, I didn't want to add all those up, so then I was just finding how many 8s there were total added up. So then I actually used multiplication. But 14, I just had to add them all up. 15, I used the formula. And then 16, I used the formula. All right, we are getting close. Oh, I forgot the what if part. What if there were 9 layers in the apple stack instead of 7? So we would have summation I equals 1 to 9. We had our formula as I squared, and that's a formula that we can use from above that says take 9 multiplied by, was it 9 plus 1? Is that what it was? It was 9 plus 1, right? Nobody's going to answer. Okay. Okay, thank you. And then it was 18 plus 1. And then over,
6.
just over 6. Okay, thanks. So I have 9 times 10 times 19. This one's not as fun. Nah, I didn't do something wrong. Am I? 6. So now I'll cancel out 3 and 2. So the 6 is gone. Like the denominator should cancel out every single time because we're adding squares. You can't get like half of a number if we're adding squares with integers. Okay. So I got to do 19 times something. Maybe I'll do 3 times 19 first, which is like 3 times 20, but then take away 1 3 afterwards. 60 minus 3. So 3 times 19 is 57, and then I'll multiply that by 5. Is it 285? Does anybody know if I got it right?
Yes.
Thank you. Okay, we're almost at the calculator part. Here's the without a calculator. Calculator part's next. All right, find the sum of the infinite series without the calculator. So this is an infinite series. We already kind of talked about it a teeny little bit. What do you think the first answer is? It's not infinity. It actually has an answer. So let's find it. We're going to start making a list. So I'm going to plug in 1 first. If I plug in 1, my a sub 1, what are we going to get? What are we going to get? 1/10. Now I'm going to plug in 2. And we're going to get 1/100th. Then we're going to plug in 3. And we're going to get 1 over 1,000. We're going to plug in 4. And we're going to get 1 over 10,000. We're going to plug in 5. And I'm going to get 1 over 100,000. And then I'm going to say, okay, I've started a pattern. I see a pattern. But I'm not quite sure because I don't really want to find a common denominator right now. Do you have an idea?
Yeah, it's 0.1 repeating.
Where are you getting that from?
Because you're adding the, so it starts off with.
Are you turning it into decimals in your head?
Yeah.
That's what I was going to do too.
Okay.
That's why I want to know how you got it. All right, so then in Marie's head, I could read her brain there for a second. She said, well, this is just like 0.1, and this is 0.01, and this is 0.001, and this is 0.0001, and this is 0.00001. So the more we add on, we're just going to have 0.1 repeating. That is a fraction. We've talked about this before.
111.
Nope, wrong, 1/9. Right, I was say you went with the wrong number there. When you have the number repeating, you put it over 9. There, we found it by hand. If it is one without the calculator, there will be some sort of pattern that you can do by hand. If it is not a pattern you can come up by hand, then this would be a calculator question. Just depends on what part it's on. All right, and then the second question, we're going to do that one by hand also. So a sub 1. 2 minus 100. Negative 98. A sub 2. What's a sub 2? A sub 3. Is it negative 94? What do you guys think? Can we add these all up together and find the answer yet? John, what do you think? I want to hear your thoughts.
I know you're adding 2 each time.
But we're adding 2 to the answer, but each time we're adding that answer. Because what we're trying to find is the sum from 1 to infinity. We're trying to find the sum from 1 to infinity. Belle, what are you thinking? You don't think we can? Like, I would put an answer like, I can't do that. Okay. What's the thing that's making it hard for you? The negatives. Okay, so we've done in our last assignment, you had to do things where you just would do like, hey, what's a sub 50? Like we just pick a random one. And could I find a sub 50 right now? What would I do to find a sub 50? 2 times 50 minus 100, right? Which would be 0. Anthony, what are your thoughts? It's just blank up here. There's nothing in here. You're thinking about other fun things like chemistry or physics or, yeah. Anthony, give me a different number to plug in, not 50. Well, lower than that, we're adding negative 98, negative 96, negative 94, negative 92, negative 90. Eventually, we have to go to infinity. So I assume every number I'm adding prior to 50 is going to give me a negative number. So let's go bigger. Give me a different one to plug in. 100. Okay. So we'll do 2 times 100 minus 100, which is 100. Okay. And remember, we are adding each of these answers on every single time, including all of the answers in between here. Connor, do you have a thought?
I mean, couldn't you just say like infinity minus whatever that are negative? Like,
What's infinity mean?
infinite.
So it's never going to stop going. So if I say infinity, take away 1, it's still infinity.
Okay. Could you write as like a range or something like that?
Infinity is infinity. I'm never going to stop going, and I'm going to keep adding on. And what kind of numbers am I going to keep adding on every single time? Bigger positive numbers, right? I'm just going to keep adding positives and positives and positives. And I'm never going to stop because infinity. Nick, you want to say something?
So wait, before I give an answer, can you go backwards?
What do you mean, can you go backwards?
Like a negative one?
No. It's just always first term. I mean, I just think the answer is infinity. Because you're never going to stop plugging answers in ever. And they're just going to keep getting more positive. So even though we subtract 98, it's still from infinity. So, and then we still keep adding more. So in my opinion, I just think it's infinity. I made kind of a challenging one so we could talk about it. But does it matter that it's even if we're going to infinity? I mean, infinity never stops.
But it's only even numbers.
But infinity never stops. We don't all of a sudden reach the end and be like, Okay, now we can add them up, but it's just the even numbers. It never stops.
If we were to graph it,
Okay.
we wouldn't have the odd ones.
Right. But if we were to graph any of these, we wouldn't connect them.
Right.
So if I were graphing this, and I think about it, okay, it's a line. So I'm going to graph 2x minus 100. So I'm going to start way down here at 100. And then I've got a slope of 2. And now I can't, I'm totally going to like space these out further than I should because that's a lot of numbers. And then it's a very bad graph. Hold on. So ignore how many dots you actually see. But, you know, I've got my slope of 2. And then I've got however many dots. And it's going to go on forever. So what I'm doing is I'm adding together the y values. And those first 99 or so numbers, or first 50 numbers, in infinity aren't even going to do anything. It's basically, we're always adding bigger numbers. It's going to be infinity. And the reason why I put this one here, and I would never give you this complicated of a question. The reason why I put this one here is you're going to have to do a question like this by hand. And I want you to notice on the one previous, we were taking an we were doing exponential. We were multiplying each time by a tenth. We were multiplying by a smaller and a smaller and a smaller amount. So you're only adding piece at a time, and it's getting smaller. Eventually, when you get to infinity, which we never get to infinity, you would be adding nothing. So we can have an answer. We can have a numerical answer if the what's this thing called? Base would be like exponential decay, where it is between 0 and 1, and each amount is getting smaller every time. But if we have a base that is bigger, or this is just like 2 times a number, it's just going to keep getting bigger, and our answers get bigger every single time, we're never going to get an answer. We're always going to add something bigger, and it's always going to end up at infinity. Chris, did you have?
Yeah, I was just kind of thinking along the same lines of like, if infinity encompasses everything, and you're only doing the even numbers, wouldn't that be like half of infinity, since you're not having everything in infinity?
But so infinity is not a number.
But
it contains numbers, but it never ends.
Yeah.
So I don't know. This is a quote from one of those very heartbreaking, cry at it, love films, and I don't remember which one. I don't remember which one it is. Maybe The Fault in Our Stars? Or there's a book too. But there's like different kinds of infinities.
Can I just say something?
Yeah.
It's, you're not like saying like, you're trying to find the sum. So it's still like keeping adding on numbers infinitely. So it's not saying it's just, it's all the numbers. It's saying that it's like building up infinitely. You, even if you include the,
I think I see what you're saying, because I think Connor was kind of thinking along the same ways. So it's not the individual terms that matter. It doesn't matter that I'm skipping numbers in between. That part doesn't matter. What matters is the sum. So if I'm throwing I'm trying to weigh something. I'm weighing apples, and I'm throwing in 2 apples at a time. It's just going to get bigger faster instead of throwing 1 apple at a time. But I'm still like going up. And if I just do that infinitely, it doesn't matter if I'm throwing 1 apple at a time or 2 apples at a time. Like 2 apples at a time, it's going to get heavier faster. But infinitely, I'm going to have potentially the same amount of apples in there instead of throwing them 1 at a time or 2 at a time. If you think about like how much the scale weighs. Does that make sense or not?
No, but it doesn't matter.
Okay. This was a fun discussion. I think we're going somewhere where we don't need to go today, but it was really interesting to talk about that. The next This is, I think, the last one without a calculator. The next one, I think, I don't remember. Yeah. This one has vocab that might sound scary. It says, find the fifth partial sum, and it says, I goes from 1 to infinity, and the formula, by the way, it doesn't have extra parentheses around it, but I keep putting these here, and you'll find out why in the next section. But infinity, 1 to infinity, 2 times 1/3 to the I. We are going to find the fifth partial sum. That means you only have to do the first 5. That's what it means. That just means 1 to 5. So this is just for vocab, fifth partial sum, because you're like, why didn't they just say that? Well, because it's learning the vocabulary. So we'll have 2/3 plus 2/9 plus 2/27 plus 2/81 plus 2/243. We're not going to do that by hand right now, okay? But that's what you would add together for that fifth partial sum. Got it, Nairi? Mm-hmm. All right, using your calculator. We are going to use our calculator to evaluate the sum where x equals 1 through 5. The formula is, and I'm going to put an extra parenthesis in, x factorial divided by 2. So we're doing our calculator. The answer is already written here. The answer is 153 halves, 153/2. But there's 2 different ways to do it because of which calculator you have. Who in here has the older calculator with the yellow button, the 83? Where's? Pull it out. So you guys, yours is a lot, but a lot more challenging. Everybody else, it's super easy. And then you guys who have the harder one, I'll do it a second way. I only have the new one on the computer, but I'll do it a second way, just doing your steps. So this is for everybody who has the newer software. Where's my calculator? Here it is. And when you do this, you'll see why there is going to be a calculator and a non-calculator section. So we go to math. Let me clear all that out. And then you're going to go all the way to the bottom, or you can just scroll up, and you'll see summation is a choice. And then you just plug stuff in. You can use whatever letter you want, but I just use X because there's a button for it, so it makes it super easy. And we're doing from 1 to, what was the top number? I'm not looking at it right now. 5, that's right. And then remember, if you do have the new calculators, alpha, y equals, enter, gives me a fraction. And then it's x factorial on top. So to get x, you just use the x button right here. But to get factorial, that's also under math. And then you over to probability. And then it's choice 4. And then I go down, and it's a 2 on the bottom, right? So then I type that in, and I get 153/2. It does the math for me. I am not learning math when I'm using my calculator. I'm learning how to use my calculator. Yes.
Is there a button that you can use to do infinity sign?
No, but we're going to do one with it that is infinity. So we'll look at that. All right. So now those of you that have the older ones, I have directions and I don't have them memorized. I got to look at it real fast because I never use those directions. You have to go sum and then sequence. Ooh, it might not even be on here actually because I have the newer one. No, it might not even be on here. Where is it? What's it under?
Stat.
Under stat?
Yeah, it's second stat.
Oh, second stat?
And then you scroll over.
Oh, it is under there. Thanks for knowing, but that's not for the other people who have the older ones, Lydia and Connor. I believe it's just under math, isn't it? For you?
For what?
It says sum. Here, I'll hit it. Like sum. Is yours just under math? Lydia, is yours under math?
It just says in direction and stuff. It's,
Oh, it says. I didn't read the directions.
it's okay.
I just looked at the sum part. My bad. So follow the directions. Which, like I said, I've taught this every year, but I always have the new calculator. So we go under. Oh, I didn't read the part above it. Okay, so second stat, scroll over to find those things. Got it. Good thing somebody reads directions. So then sequence. No. What did I do wrong? Maybe I just have to hit no. Okay, I don't think I can do it on here. I was going to try. I don't think I can. I'll help you guys if you can't figure it out. Lydia, did you follow directions and get it? Connor, either of you? Okay. So one thing that I know from helping people in the past is just, you type in your sum and then you type in your sequence. And then you might need an extra parenthesis, probably for not this one, but you might need an extra parenthesis when you have more complicated ones to type in. But this one you probably just type in as x factorial divided by 2, comma, x, comma, 1, comma, 5, parenthesis, parenthesis, and then it should give you the exact same answer. That it might give you a decimal, but then you can hit math, enter, enter, and then it'll turn it into a fraction. Did it work for you? Okay. So Connor, if you have any trouble, I can come help you. So we're going to do, we're going to evaluate these using the calculator. So this next one does have an infinity. So I want everybody to type in everything except for the infinity. We'll go over what to do there. Okay, so with the exception of the infinity, you can type everything in. We can't type in infinity. So what we're going to do is we're going to start putting numbers in and see what it's getting closer and closer and closer to. Sometimes we can put in little numbers and find the answer. Sometimes we have to put in huge numbers. Sometimes if you put in a really, really big number, your calculator just thinks forever and then gives up. So it's kind of like there isn't a rule of what numbers you should try first. But you got to just try a few to see when it starts changing. I'm just going to try 10, and I'll put it in there, and I hit enter. And then I'm going to hit second enter, and I'm going to go change that 10 into a bigger number. Now, if you hit enter and your numbers don't match mine, then there's something you're doing wrong. So I chose 10, then I chose 20. They're not the same number. So I'm going to try something bigger. I'm going to try 30. I'm going to go second enter and get that equation again and just go change it to a 30. Okay, when I chose 30, I got the same answer 2 times in a row. That means I found the answer. Once you get it multiple times in a row, that's the answer. So I can see it's 8 1/3. We will not be typing in 8 1/3 in Canvas ever, so I'm just going to change that to 25/3. And you can't type in a repeating number in Canvas, so you wouldn't write it as a decimal. You write it as a fraction. Okay? So the second one, I want you to do the same thing. I want you to start plugging in numbers until you think you have an answer. And I'll just wait for a moment. Start plugging in numbers until you think you have an answer for that next one. And I think that's the last one. Yep. John, did you get it? You may stand over you and like watch you type this in your calculator. Oh, dang.
My batteries.
That was like weeks ago.
Yeah, I know. We don't have to check with them.
Aren't you 18?
Yeah, I just haven't gotten it.
Uh-huh. So don't blame it on your dad. Do you drive to school?
Yeah, I did
Oh
that.
my gosh, no, not for school. On the way home. On the way home from volleyball. You got no more excuses. Do you have Amazon Prime?
Yeah.
Oh dang, just order them now. It'll be there in like 2 days. Or do you not have are you not allowed to buy stuff on it?
I don't have the password to buy stuff.
You what?
I don't have the password to buy stuff.
Oh, that was smart of your parents. I should probably not have the password to buy stuff. But I like when presents come, even if I bought them. I like when they come to me. Did you get the answer yet? Where's your calculator? Do I need to give you a hard time too? Why didn't you ask me on your lap the last time we're gonna need our calculator? Here? You brought your what?
I like mixed up in my head English and math.
Oh, you mean between 2 days, A and B day? I was like, you forgot. You just don't take that everywhere you go though, like just always have it.
You want it like a virtual contact.
Okay, remember how I said, if you have an issue, come tell me. You have you like closed a parenthesis somewhere. No, maybe you didn't open a parenthesis. No, you closed it somewhere along there. Oops. Here, finish this one. I'll come back to that. Okay, what did we get? What'd you get? Caitlin, what'd you get?
I didn't get anything.
You got nothing. Oh, you don't have a calculator either? Oh, okay. Well, what do you mean you got nothing?
Well, because they don't know like a high enough number to type.
Yeah.
Like, they're just like,
Then what is happening? We're typing in bigger and bigger and bigger numbers.
I just know it's infinity because.
Oh,
it's
then you
not
do
a-
have an
Well,
answer.
it's not a fraction, so
Not
it's.
me, she does.
Okay, but we're adding on bigger and bigger and bigger numbers. It doesn't matter. Remember, I was talking about this earlier. If I'm adding bigger numbers and then more bigger numbers and then bigger numbers, it's never going to reach it on the calculator because we can't reach infinity.
Which is why Caitlin didn't have an answer because.
It's never going to reach it. So that's where you need to say, hold on. If I keep adding bigger numbers onto bigger numbers onto bigger numbers forever, that's infinity. So you won't even see it on your calculator. It won't say, hey, this is infinity. You have to know, oh, that's going to be infinity because I'm adding bigger numbers onto bigger numbers and bigger numbers. It's going to get bigger forever. Okay? All right, so that's it for our notes.